Hello guys, welcome to my channel Code with Maddie. In our previous video we have talked about this question to find kth largest smallest element in array. So in the previous video we have seen a different approach to solve this problem, and that's a simple approach to solve this problem, in which we have come up with a solution, and we have seen the complexity of that problem as well as the space complexity of that problem. So in that case, we have seen that time complexity is coming as big O of n log n. So as I have said, we will optimize this solution in the upcoming videos. So in this video, I have tried to optimize that solution, in which I have tried to optimize that time complexity less than the time complexity which we are having there. So let's start with this topic of today's content, to find kth largest smallest element in array. And today we will be solving this problem with the help of min heap. So as you guys know that these all questions are very important for interview point of view, as well as your coding competitions, wherever you are going to sit for those competitions or interviews. So they will be definitely asking you with this question that try to optimize this solution, because everywhere what will happen means what will be the advantage of optimizing our solution. So that is what means it will increase your performance of your application anyhow. Okay, if your time complexity will be low, then in that case your performance will be high, and if your time complexity will be high, then your performance will be low. So that is why optimization is very important. And today I will try to just solve this and try to optimize, and we will see everything related to that in this video. So let's start with the content. So as we have discussed, the problem is to find kth smallest and largest element in unsorted array. Okay, and if we talk about the difficulty level of this question, so difficulty level, I have already told you guys that it has a difficulty level of type medium, and this is very general and common question to be asked in every interviews and coding questions. So what is the problem statement here? So let's go ahead. So what we will have is, we have an array as an input and a number k as an input. Okay, and where k is smaller than the size of the array. And why is this k is smaller than size of array? Because we have to find kth smallest number, correct, in a given unsorted array. So if that k will be greater than the size of array, it is out of bound question, that we are trying to find some value which is not present in the array. So that is not the case here. We are given very clearly that k is smaller than the size of array. Okay, now let's go ahead. We need to find kth smallest element in the given array. Okay, now it is given that all the elements in the array are distinct. Okay, no any element in the array are repeating itself. Okay, so now let's see some examples. So we have here input array. In the first example, we have 6, 9, 3, 2, 19 and 14. Okay, and key is also given as 3. So what should be the kth smallest element here? Third smallest element. So first of all, let's see what is the smallest element. So smallest element is 2, then second smallest element is 3, the third smallest element is 6, hence our output will be 6. Okay, similarly for the next one, when we are sending same array and k is giving as 4, so in this case what should be the fourth smallest element? Third smallest element we have seen in the above example, that is 6. So what would be the next fourth smallest element? That would be 9. Okay, so we have seen this to solve using simple approach in which we are simply sorting this array, and we are returning k minus 1 of index from the array. Okay, but now we will not go by that approach, because that approach is having the time complexity of big O of n log n. Okay, so we will try to minimize optimize this solution, sorry. Okay, so let's move ahead. So what is the solution for this? So we are using min heap to solve this problem. Okay, so what are the steps to solve this problem, or we can say algorithm to solve this problem? So first step would be, we have input array. What we will do is, first we will create a min heap from all the array elements which are given to us. Okay, we will create a min heap, and then we will extract all the minimum elements from the min heap k times. Okay, now the point will come, what is min heap, and what is this extract min, all those things. So this I will let you know in the upcoming slides. Okay, so now if I talk about this algorithm, so this have the time complexity. What is the time complexity in this case? Big O of n plus k log n. Okay, and space complexity big O of n. Now if we talk about our simple approach, so there we are having big O of n log n as a time complexity. Okay, so time complexity is n log n. It is proper in the n log n format. Now here it is not n log n, it is k log n, and it depends upon the value of k, not to the value of n. Okay, and remaining is n plus. So that would be, we will see in the comparison graph for that time complexity comparison graph. In that it will be more clear. Okay, so as we have discussed what is binary heap, that I will tell you right now. What is binary heap? So binary heap is nothing but it's a complete binary tree. Okay, with the property that all the levels are completely filled except the last level, and the last level has all the key as left as possible. Okay, so binary heap is nothing but a complete binary tree. Okay, and if we talk about uh, the property, what is the property along with the complete binary tree? So that property would be, all the levels will be completely filled except the last level. Okay, and all the keys will be, as much as possible we have to keep all the key as left. Okay, okay, now we will see uh, the next slide. So what is binary heap types? Okay, so there are two types of binary heap. Okay, one is max heap and min heap. So only these two heaps are only possible in binary heap. So what is min heap? So min heap is nothing but we have to min heap is containing the values like the minimum element among all the key present in the binary heap. The minimum among all of that key will present at root node of that min heap. Okay, so minimum will present at the top of that binary heap or root of that binary heap. That is why that is known as min heap. And max heap, where it will be maximum element will be present on the top of the heap or the root of the heap. That is the max heap. So let me tell you the example of binary heaps. Okay, so we can see here the max heap and min heap. Okay, so if you can see here, okay, so we have this max heap. Okay, in this, if you see the values of the keys, so looks like 15 is the root node of this binary heap, and as well as 15 is the maximum of all the keys present into this binary heap, correct? So this is a min heap. Now complete binary tree, why I said this is a complete binary tree, it is completely filled. Okay, see, all the roots is completely filled except the last level node. Okay, so this is an example of max heap. Now this max heap can be represented in the form of array. Okay, and for representing it in the form of array, we have to traverse this binary heap into level order traversal. Okay, what I mean by level order traversal, level order traversal is nothing but like this. First it will contain 15, then it will contain 8, then 10, then 5, 3, 7, 1, 4, 2. Okay, into level order. Whatever the next level will come, in the order wise, all the elements will be arranged into this array. Okay, so let's just cross check once. In the array we will see first 15, then 8, 10, 5, 3, 7, 1, 4, 2. Okay, so this is the array representation of above max heap. Similarly, we have min heap. So in min heap, as we have discussed earlier, it will contain minimum element on the top of the min heap. Okay, so here if you see, and also if you notice in the max heap, so not only the maximum will contain on the top, but if you look at the inner levels also, so in this let's say this example, so 8, 5, 3, in this 5 and 3 is less than this 8. Okay, this will contain also maximum of the below ones. Okay, see this one 10, this is maximum of 7 and 1. Similarly, if you see this 5, so this is maximum in 5, 4, 2, correct? Similarly, we have this property in min heap as well. In this, if you see 15, 16 and 22, so at the parent node, it will contain minimum of these three values. So 15, 16, 22, what will be the minimum of these three? 15. So it is here. Okay, now similarly if you see for this level at 9, so 15, 10, 9, 16, 22, what is the minimum? Is 9. So it will contain 9 at this level. And if you talk about the root level, so it is 1. It means it is minimum among all these values, correct? So this is min heap. And also the array representation is same, level order traversal we have to do, and we have to store it into the array. So if we will store it, so what will be the value? 1, then 9, then 3, 15, 10, 7, 8, 16 and 22. Okay, similarly level order, we are going level by level, and in the same order we are storing it into the array. So this is an example of max and min heap. Okay, now array representation of binary heap is having some advantage, like we can tell like let's see what is written here. So in the array representation of the binary heap, we are having root element, right? So root element will always be at array 0, correct? As we have seen in the previous slide, so in this both min and max heap, the root element is always present at array 0. Root element is always present at array 0, correct? Okay, now other keys of binary heap can be shown as below indexes for ith node. Okay, so what I mean by this is, let's say if you are on ith node let's say 9, okay, and here you are on the ith node. Now if you want to check in this array representation what is the left node of 9 and what is the right node of 9, so that you can see using, you can check using these three conditions. Okay, so this will give you array I minus 1 by 2 will return the parent node. Okay, I minus 1 by 2 will return the parent node. 2i plus 1 will return the left node. Here this is a type of mistake, so this will return the left node, and 2i plus 2 will return the right node. This is a typing mistake, I guess it's a copy paste mistake, so I will just change this later on. But you can see the examples that is being taken into the coding part. I will tell you there we have used this to fetch left, right, and parent node. Okay, now next part is what is that level order traversal. Okay, so that is what just it is here also explained what I have just told you. So let's say this is a example 1 3 6 5 9 8. Okay, so for representing this is the array index we can give. So 0 index is first root element, 0 index, then 1, then 2, then 3 4 5. So in the same level or in the down level by level we are ordering the elements and storing into the array. Okay, so we are here, and so before proceeding with the dry running, so I will suggest let's go through the coding part of this. Okay, so before going to the coding part of this one, so just let's first again revise our algorithms part. So what is the algorithm it is saying here? We have to first create a min heap of the given n elements. Okay, and next step is we have to call extract min k times. Okay, so we will implement this into our code. So I'll just open my workspace, and yeah, so this is here. I have already written the code for this one, since it's very lengthy code, so it's better to, I will explain everything one by one. Okay, so let me go to the main method of this class. So this class, whatever we have discussed on the previous video, so this class already contains that code as well. So this we have discussed earlier, in which we are sorting the array and we are doing all those steps. Okay, and we are calling this here. So I have commented out for now, because that we are not using here. This method we are not using anymore here. So we will create one more method, this method find Kth-Smallest using min heap. Okay, using min heap now we will find the Kth-Smallest. So this method I have created. So from our main method we have been given these two inputs, input array 6 9 3 2 19 14, and k, variable k, which is we are using to find the kth element, Kth-Smallest element into the array. Okay, so this line is nothing, it's just creating the object of the class to call this method. Okay, so we have created the object to call this method. So let's see what is inside this method. So inside this method, see, I have already told that comment is very important for writing any code and for understanding the code. So that's why it is a very good practice to always put a comment whatever the code you are writing into your system or anywhere. Okay, so that reader of that code can also understand what you are writing and how the things are moving step by step. Okay, so this method is used to find Kth-Smallest element in the given array. Okay, we can also give here using min heap. Okay, so now, so as algorithm said, we have to first insert all these array element into min heap. Okay, or we have to convert all these input array into min heap array. Okay, so for min heap I have created one inner class. So in this class min heap, I have created one constructor to create min heap from the given input array. Okay, so I am directly calling from here that min heap, and what we are storing, this input array and size of the input array. This we are going to store into the min heap. Okay, so let's go to this min heap constructor. So here we are having this constructor. Okay, so here what we are trying to do is, so let me go through top of this first and then it will be more clear. So in this min heap class, so this class is basically created for storing min heap objects, that's all. Okay, all the min heap objects and methods all will be stored into this class. Okay, so here I have created one array object which is a heap array object. Okay, so this heap array object is nothing but this heap array object is same as this array representation. I told you that this min heap can be represented as array. So for doing that same, we are using this array representation here to store the values into heap array. Okay, so that's why this object is being created. Now this heap size is nothing but then it's only array's size of that heap. Okay, now as I told you, we have some methods into this to find left parent and right node corresponding to ith node, correct? So this I have used there, and I'll show you that also. So if you see here, this will return the parent node index of current index I. Okay, whatever the current index I you are currently present, then at that current index I, or let's say here I have used node, so it's better to keep it as node. Okay, so this at this node index you will be returned as node minus 1 divided by 2. Okay, see, node minus 1 divided by 2 will return the parent node. Okay, now for getting left node, we will be returning 2 into node plus 1. Okay, see, 2 into node plus 1 will be returning the left node. Here it is a typo mistake. Okay, now similarly for right node, we will return 2 into node plus 2. Okay, this we can see here in example as well. So if you see here, so let's say currently you are on node 8. Okay, and you want to find the left node and right node of this 8 into this array. Okay, so here you are at node 2. Okay, so node 2 you are currently, and you want to find left node. So for finding left node, what you will do, 2 into node plus 1, right? So 2 into node, what is 2 into node? So node value is, node index is 2. So 2 into 2, 4 plus 1, that is 5. Okay, so see, this 5 is the left value. Similarly, right value will be coming as node plus node into 2 plus 2. So means 5, if it is the left node, then just after that element will be right node. So 8 will have 5 as a left node and 8 will have 3 as a right node. Okay, so this we are using to just fetch the parent, left and right node. Okay, now for min heap, what should be the minimum element from the heap? See, from the min heap, if you want to see from the min heap, what is the minimum element? Minimum element is nothing but the value which is present at the top of the node, top of the heap. Okay, and this top of the heap will always be represented at array 0, correct? It is always being represented as array 0. So for getting min value, what we will simply return? whatever the zeroth value index, zeroth index value, whatever will be present into heap array, that will be simply returned from get min method. Okay, so this is also clear. Now coming on to the constructor part. Okay, so constructor part, what it will do is uh, we are calling this constructor to store all this input array into the heap array, which we have seen here. This heap array will contain all those input elements into this heap array, and it will also apply the properties of min heap, that minimum element should be on the top of the heap. Okay, so for this constructor we are just initializing heap size at the current size, whatever current size of the input array we are getting. Then heap array, we are directly storing whatever the input array we are getting from the heap input, we are storing into the heap array. Now we will find the index, we will find the index of middle index, you can say middle index of that heap. So heap size we are having whatever the size of input, so currently we are having size 6, right? From here see 2 3 and 3 elements, so total 6 elements we are having in this input array. So heap size will be coming as a 6. So 6 minus 1 divided by 2, so that will be coming as 2. So now we are trying to create a min heap using while loop. Okay, so inside this while loop what we are doing, we are min heapify, we are calling a method min heapify. So okay, so min heapify method will do nothing. If we go to this method will use to heapify the remaining nodes of the heap. Okay, means maintaining the property of the min heap of remaining nodes. Okay, whatever the, see, we will add the min heap directly. We have added all the elements into the heap array directly here, but this time it will not follow the property of that min heap, that minimum element is not at the top currently. Okay, see, minimum element is not currently at the top, current top element is here 6. Okay, that is not the minimum one. So for maintaining that property we are using this min heapify method. Okay, so this min heapify, wherever it is being called, it is simply maintaining the property of remaining nodes into the min heap. Okay, so this will convert, means this while loop will convert this heap array into a min heap array. Okay, so we will see all those things step by step into dry running case. So let's move further now. So next method we are having is extract min. Okay, so for now till here, if we see here, we have called Kth-Smallest using min heap, and here we have converted our input array into min heap. Okay, now what is the next step into algorithm? Next step into algorithm is saying that you have to extract the minimum element from that min heap. How much time? K minus 1 time. Okay, means if here we are having k as 3, right? Let's say this is converted as a min heap. Okay, so it will contain minimum element at the top. So for extracting min, what should be the step for extracting min? So first we will extract the first root element. Okay, so if you go to that extract min method, so here we are extracting the root element from here, and we are storing some random value from the heap into the root element, and we are again heapifying that, so that property of the remaining nodes in the main heap can maintain. Okay, so we are extracting it and we are heapifying that. Okay, so since k is 3, okay, so we will do extraction part k minus 1 time, 2 times only we need to extract, and at the third time we will simply get the minimum and return it. We don't need to extract it kth time, because at kth time that minimum element will be present on the top, and we can simply use get min method to return it. Okay, are you guys with me this time? Okay, so this extract min is we are using to extract the value from the top root element and heapifying that. So that task it is doing. So it is clear, extract min is clear. Okay, heapify is clear. In heapify it is doing nothing, it is just calling L and R, that is left and right value, and it is storing one smallest element. Okay, and it is comparing with left and right value and storing the smallest of that. Okay, and again it is calling min heapify for the remaining nodes, so that all the elements present into the heap can maintain the property. What I mean by all the elements means, it is not necessary that only one is present here and that is a minimum element, then it is a min heap. It should not be like that. It should be like, if 9 is present here, then it should, the child of this 9 should be greater than 9, right? If 3 is present here, then 7 and 8 should be greater than 3, the child of this 3 node. Okay, so that is maintaining here in the min heapify. Okay, so this will return the minimum element from the extract min after doing extraction and after first. So let's again revise this method once again. So what it is saying, first step is we have to take the input array and we have to store all this input array into the min heap. Okay, and min heap is nothing but a constructor in which we are simply storing all those value into heap array, and we are heapifying that heap array elements. Okay, heapify means we are maintaining the property of min heap. Okay, now next part is we are extracting the k-1 element from the min heap and finally returning the get min from the top of that min heap. Okay, so this is all about this code. Now let's run it and see what is the output coming. So third smallest element is coming as 6. Okay, so let's try to change this k. Let's say give this 4, save it. Now do a run as and give it as. So now see, fourth smallest element in the given array is coming as 9. Okay, now we will see what is I was saying about dry running it, so you will be more clear with that. So see, for dry running this test case, what is the first step? First step is simply whatever the input array we are given. So this is the input array we have been given, 6, 9, 3, 2, 19, 14, and indexes are this, and k we have been given as input as 3. Okay, now step 2. In the step 2, what we are doing, we are storing the given array into a min heap and heapifying it so that it can maintain the property of min heap. So after storing it, after doing that, after storing those array elements into this min heap, how the min heap will look like? Min heap will look like this: 2, 6, 3, 9, 19 and 14. Okay, in which you can see the property minimum element is at the top. If you see at this level, so this is the minimum element among 6, 9, 19, and if you see at this level, so 3 is minimum among 3 and 14. Okay, and 14 is the, if only one node is there, so it should be added into the left much as possible. It is added as a left node as much as possible. Okay, so after first step, our main heap will look like this. Now how array representation will look like this? So what would be the array representation of this min heap? So simply here we have to do nothing, we have to simply do a level order traversal. So level order traversal, I told you, first 2 will come as a array 0, then 6, then 3, then 9, 19 and 14. See, 2, 6, 3, 9, 19 and 14. It is represented as array. Okay. Now here if you see, the minimum element is on the root and also it follows the properties of min heap. Okay. So here you can see, now if you want to see this into your code, or you want to debug your code, and if you want to see this tree structure into your code, you will not be able to see, because we are not maintaining any tree structure into our code. Okay, we are storing this min heap in the form of array, and the array is having the label order traversal of this min heap. Okay, so this you can see into your debugger. Debugger will point to the array, and if you open that array, so in that array you can see the elements are stored in this manner. Okay, so now coming on to the next step of this dry run, what next part we have to do, we have since we have to find third smallest element, so we will extract minimum 2 times from the heap. Okay, as I told you, k minus 1th time we have to extract the value. So if you go back and if you see here, minimum element is 2, right? Now 2 will be extracted. If 2 will be extracted, and if you go to the code and see what we are doing into the extraction part, extract min, in this extract min we are extracting this root node, and to this root node what we are adding, we are overriding this root node with the last node of the heap array. Okay, so in this case, what is the last node? Last node is 14, correct? This is the last node. So once 2 will be extracted, so instead of 2, what we will be having, we will be having 14 here. Okay, now we will be having 14 at the top here, but after that also, if you see into the code, we are heapifying it. We are heapifying the remaining change, means we have performed the changes into the heap array. So now it is not necessary that it will be the min heap currently, so we will heapify that so that it can contain and it can maintain the property of min heap. Okay, so here now let's say the next part, here 2 is extracted, and now after heapifying, the minimum element should come at the top, that is 3. Okay, and 14 will occur 2 times because we have overridden that 2 previous 2 with 14, correct? So that is why 14 we are seeing 2 times. This is coming after heapifying that. So after heapifying, after first minimum extract, heap will look like this. Okay, root node will be extracted, and as this is a min heap, so it will contain min heap on the root node. So minimum element on the root node, it will contain minimum element on the root node. Now array representation of this, you know that it will be 3, then 6, then 14, then 9, 19 and 14. Okay, now if you want to perform second minimum extract, so second minimum extract, similarly here we are having 3 as a minimum, so we will remove this, or we will override this 3 value with last element. So last element is what? 14, right? So we will override this, sorry, so after overriding, 3 will be overridden with minimum element, that is, and after heapifying as well, so it will be overridden with 6, and the value coming as n minus 1, that is 19 will be repeated. See, n minus 1 is 19, correct? So 19 will be overridden with 3 value and it will repeat itself. So 19, 19 and 14 was the previous one. So 6 will be at the top, and here also you can see it is maintaining the properties of min heap properly. Okay, so now after second minimum extract, heap will look like this, and at the root node of this heap we will have the minimum element, and that minimum element will be 6. Okay, now finally, since we are having only k as 3, so we will only extract 2 times, not more than 2, because at third time if we are going to extract it, it will remove that value and we will get some other values instead of this 6. We will get 9 here. Okay, and that will not solve our problem. So at the last step, what we will do, we will simply use get min method to get the minimum element from this min heap. And what is the minimum element of this min heap? Currently it is 6, so that is why 6 will be returned from this method and our result will be coming as 6. Okay, so this is the part of the coding for this approach. Now we will discuss the complexity of this solution. So if you talk about the time complexity of this solution, so time complexity is coming as big O of n plus k log n. Okay, where n is the number of elements in the given array and k is the smallest number. Okay, this is k is the input which we are giving. We have discussed this, how this is coming. So here if you read it, so time complexity for storing value into min heap is big O of n, because for every n it will try to min heapify those values. Okay, and for extracting k element it is k log n, so that is why total time complexity will be coming as n plus k log n. Okay, now auxiliary space complexity if we talk about, so this is big O of n in this case, because we are using an array to store the minimum heap, right? We are using heap array to store the input array into the minimum heap, so that is why one auxiliary space complexity of this solution increases. Okay, now discuss about this time complexity comparison graph. So in previous case, in the simple approach we have seen, we have big O of n log n time complexity. Okay, but in this case the complexity is somewhere in between big O of n and big O of n log n, because it is big O of n plus k log n, not n log n, correct? So it will be somewhere in between these two. Okay, and previously it was on this curve. Okay, so we have finally reduced this complexity and we have optimized this solution below this curve. Okay, and we always try to optimize this we always try to optimize any solution to the below of this curve or below of any curve. We have to not fall. If you see the color of this curve, all these colors, so below one is showing as pure green, then green, light green, then red, complete red. Okay, so red is not favorable to us. Okay, we have to stick to the green part. Okay, so in this manner we have optimized this solution, and for that code I will just commit that code into my Git repository, and you can check that code from there, and I will also mention the link of that repository into the description of this video. Okay, you can go through that code, and if you feel any question anytime, feel free to reach out to me anytime. Okay, uh, for contacting me, I have already given the description into my channel. You can go through from there, or I will also add that contact point into this below this video description, so you can go from there as well. Okay, and so in this way we have optimized this solution, but this is also not a perfect solution, we can say, because there are more than many way to solve a problem. So it's not we can say that it's a perfect solution. So we will try to optimize this solution more in the upcoming videos. Okay, and if you want to see what are the optimization solution that we can come up with, so please subscribe my channel for more such videos, and be in touch with me. I have already created one Insta page and LinkedIn page. You can join with me there, and you can ask me queries as well anytime, any when you want to contact me anytime. So please subscribe my channel and give a like to my videos for more such video. Okay. And feel free to reach out to me anytime. Thank you guys. Thank you so much.